Hello and welcome to the OCR Further Maths videos for Pure Core. This is Hyperbolic Functions 2, Inverse Hyperbolic Functions, and this is video 2.4, Integration using Hyperbolic Substitutions. So other videos will go through using trig functions in detail, and here we're going to look through one example of using a hyperbolic function in a substitution. Using substitution can be a good way to integrate an expression. For example, if we have a function that involves the square root of x squared minus a squared, we can see that that relates to the functions that we've been looking at in previous videos, and we can use the substitution x equals a cosh u. So here we're going to look at an example, and we're going to use a substitution of form x equals a cosh u to find the integral of the square root of x squared minus 9 with respect to x. In this case, we're going to choose a equals 3 because we've got this 9 here and we want to get rid of that, and we'll be able to take it outside of the integral. So we're going to use x equals 3 cosh u, and that means that 3 will be able to come outside when we switch the variables. So we can rewrite this integral using substitution as the integral of the square root of x squared minus 9 dx is equal to 3 times the integral of the square root of cos squared u minus 1 dx du. This part here is so that we can change our integral to integrate with respect to u instead of with respect to x. So we know that cos squared u minus 1 equals sine squared u from our identities, and we also know that if x is equal to 3 cos u, then dx du is equal to 3 sine u. So we can rewrite this integral as the integral of the square root of x squared minus 9 with respect to x is equal to 9 times the integral of sine squared u with respect to u. Okay, so we're now going to continue with this example. Now we know that cosh 2u is equal to 2 sine squared u plus 1. We can't integrate sine squared u, so we're going to need to rewrite it in terms of cosh 2u. So 2 sine squared u is equal to cosh 2u minus 1. So sine squared u is equal to cosh 2u minus 1 all over 2. So this integral x squared minus 9 with respect to x becomes 9 over 2 times the integral of cosh 2u minus 1 with respect to u. Now we have something that we can actually integrate. So when we integrate this, we get 9 over 2 times by a half sine 2u minus u plus c. Don't forget this plus c. So we can rewrite this as 9 over 2 times sine u cos u minus u plus c. That's because sine 2u is 2 sine u cos u. Now what we want to do is change our variables back. So we know that cos u is equal to x over 3, and sine u is equal to the square root of cos squared u minus 1. So that is the integral of, the square root of x squared over 9 minus 1. And we also know that u is inverse cosh of x over 3. So if we substitute all of these back in, we have that our integral now becomes 9 over 2 times by x over 3 times the square root of x squared over 9 minus 1 minus inverse cosh of x over 3 plus c. And so simplifying, we get 3x over 2 times by a third square root of x squared minus 9 minus 9 over 2 times inverse cosh of x over 3 plus c. And so our final solution is x over 2 times the square root of x squared minus 9 minus 9 over 2 inverse cosh of x over 3 plus c. And we can see here a neat version of that. The important thing to remember is if we are doing an integral that is not between limits, we do need to remember to change back so that we're in the original variable. If you're integrating between limits, you can change your limits, and once you've got your integral in terms of u, you can use your u limits in order to solve that. And that's the last video in the hyperbolic functions to inverse hyperbolic functions section.